Hello everyone, this is the solution video to NPTEL Digital IC Design 2024 assignment for week 1. So over here we have the assignment common data and the opening node, which gives the unified uh, VTH equation and the unified current model for NMOS and PMOS, right? So the idea will be that all the questions relate to some drain current calculation for NMOS. I will go over each of them. I encourage you to pause and calculate the value yourself and check against the calculated value. So question 1, when VDS is equal to 0, there cannot be any current, right? That just follows from the fact that Vmin will be VDS, and so it's just 0. So for question 2, I have given the value of threshold voltage, Vmin, and the drain current over here. The region is velocity saturation, and that's because VD sat of 0.5 has come out to be the minimum value, and so that is the region, right, which is the answer to this question. Here we are asked to find the threshold voltage of the transistor. So VSB is 0, which means there is no effect of this gamma, which means it's just 0.4, right? And over here we are asked to find the value of Vmin and ID for the given operating point. So Vmin is 0.51. It came out to be VGS minus VTH. And since this is a long channel device, there is no VD sat, so it's therefore saturation. The current value is 78.03. Right, so and here it's just the region that we calculated previously. In question 7, again VSB is 0, so therefore we have a value of 0.4 for the VTH, right? But over here, if you see, the region came out to be linear because VDS was the minimum, and correspondingly here is the current value, right? So this is just the region for the previous problem. Interestingly, in this problem we have a non-zero value of body bias, and because of that the threshold voltage is actually lesser than the threshold voltage without body bias, that is 0.4. So it has gotten less than 0.4. Now we're back to short channel transistors, right? This is just the threshold voltage again, right? And over here we have the region coming out to be saturation, and that's because VGS minus VTH, since I'm sorry, again this is a long channel device, right? And VGS minus VTH is the minimum, so therefore it's saturation. Correspondingly the current is 75 microamps. The region is saturation. In this problem we have a positive bias for the body, which means the threshold voltage has increased, and it's a short channel device, but still, just because VGS minus VTH has come out to be minimum, it is saturation region. This is the current of this is the drain current of the NMOS, right? And this is just the region of the device. And finally over here the threshold voltage of the device, right? So those are the questions for assignment of week 1.